Hi class, welcome to this new video of Student 7, where together we will solve question 7. You are asked to prove that a transformation T from R2 to R3, where TAB equal to T plus B to A is a linear transformation. Secondly, you are also asked to prove that S from R2 to R3, where SAB equal to B square A is not a linear transformation. As a solution, let me give you a quick reminder that a transformation T is said to be a linear transformation if two conditions are satisfied, right? Which are, let's consider two vector u and v belonging to R3. If tu plus v equals to tu plus tv, then T is said to be closed under vector addition. If we have a scalar alpha, right, then if we have T alpha u equal to T u, therefore T is closed under scalar multiplication. If these two conditions are met, therefore we say that T is a linear transformation. Now, let's have a look on the first question where you have to prove that T is defined as TAB equals to AB, B to A is a linear transformation. Now, let's consider x equal to x1, x2, and y equals to y1, y2, right? Let's find tx plus ty is x plus 1, x2, 2x1, right? We are simply expressing this at given here, by replacing the variable a and b by x1 and x2. And then also, we do the same here by replacing a and b by y1 and y2 here, right? So this will give me x1, y1 plus x2, y2 plus x2 y2 plus 2x1 plus y1. Now, this therefore, as we can see, will lead to x1 plus xy, x2 plus y2, which is tx plus y. So, since this equal to this, tx plus ty equals to tx plus y, therefore, t is closed under vector addition. Now, let's look at the second condition to see if t is closed under scalar multiplication. Okay, so if we consider that x equals to x1, x2, right, belonging in the space R2, and then we consider a scalar of R, let's see if t alpha x, right, by replacing in I have t alpha 1, I have t alpha x1, and t alpha x2, and t alpha x1. Because if you see the way that t is defined, because we need to follow this along, right? It's a plus b, b to a. So at the last term here, I have a, right? And a is yeah, a is defined as a first component in the vector. So that's why I put here x1. So this will give me alpha x1. Now I replace the expression like here, alpha x1 plus alpha x2 and alpha x2 and 2 alpha x1, right? So this is equals to alpha x1 plus x2, x2 and 2x1, which is equals to alpha t x. Now, since this is equal to this, right, we have that t alpha x is equal to alpha t x. Therefore, we say t is closed on the scalar multiplication. Now, we have seen that the two conditions are met. Therefore, we conclude that t is a linear transformation. Let's see the second question. Let's prove that S is not linear transformation. S is defined as SAB equals to B squared A. Right? Now, we need to show that one of the two conditions fails. And to do that, we can use a counter example. And the easiest way to give a counter example here is to use an example from the scalar multiplication. Now, let's assume that alpha equals to 2, A equals to 1, and B equals to 1, right? We are using here, we want to check if it is closed on the scalar multiplication. That is, if S lambda U, for instance, equal lambda S U. And in this case, we are checking if S alpha A alpha B equal to alpha S A B. Right. So if we take for instance that alpha is 2, A is 1, B 1, right? So we have that S alpha A alpha B equal to S 2 times 1, 2 times 1, which equal to S 2, 2, right? S 2, 2, if I use this formula, I have 2 squared 2, which equal to 4, 2. Now, I have found this. Now I need to also find this. So to find alpha SAB, alpha is 2, SA is 1, B is 1. So is equal to 2 times S11. I can use this formula as well. So 1 square 1, which is 2, 1, 1, which equals to 2, 2. So we can see that 2 4 2 is different from 1 1, right? Which means that S alpha A alpha B is different from alpha S A B. So we just took an example and we were able to prove this. Therefore, we can conclude that S is not a linear transformation. So guys, in this video, we show you how to prove that a linear transformation, how to prove that a transformation is a linear transformation by assuring that these two conditions are met. And then also we show you how to prove that a transformation is not a linear transformation by showing that one of the two conditions fail by using the counter example. Thank you very much. See you in the next video.